Hello, my name is Matthew Su, and today I'll be discussing the physics of guitar strings. First, to discuss pitch. Pitch is the property of a sound that allows us to perceive sounds as higher or lower based on their frequencies. High frequency is for high pitch, and low frequency is for low pitch. Pitch is very important for guitarists, as it helps them know which notes to tune to as well as play to. The pitch of a vibrating string depends on four things: the string that is being played, the materials the strings are made of, the tuning of the strings, and the length of the string that is free to vibrate. The first pitch determining factor is the string being played. For string steel guitars, the strings get thicker from high E, which is shown at the top of the image above, to low E, which is shown at the bottom of the image, and thus contain more mass per length than the strings that are closer to low E. As we know from our class lectures, linear density can be related to the speed of a wave via the formula v wave equals square root t over mu, and the linear density can be given by the formula mu equals m over L. Since the frequency of any harmonic can be calculated via the formula Fn equals nv wave over 2L, the linear density can be indirectly related to the frequency via the formula Fn equals n times square root t over mu over 2L for any harmonic being studied for a string that is closed at both ends. So, knowing this, we know that playing strings that are thinner and thus have a less linear density, such as high E, B, or G, have a higher frequency and thus a higher pitch. The materials that a string is made of can affect the sound as well. Acoustic guitars, which have strings made out of materials ranging from bronze, brass, and steel, have a much greater tension associated with them. Classical guitars are made out of clear, black, and rectified nylon and have a much smaller tension associated with their strings. Again, according to the formula Fn equals n times square root t over mu over 2L, we can conclude that acoustic guitars produce sounds with a much greater frequency than classical guitars, as the increased tension that comes with acoustic guitar strings results in a greater overall sound frequency. The tension in the strings can also be changed via the tuning pegs on the top of the guitar. Tuning up, or tuning a string to a higher tension by turning the peg counterclockwise, gives higher frequency, resulting in higher pitch. Once again, this can be proven mathematically via the formula Fn equals n times square root t over mu over 2L. As tension increases, so does the frequency and therefore the pitch of any harmonic being studied. Finally, the length of the string that is free to vibrate can affect frequency as well. If one shortens the string or places their finger down on a higher fret, a higher frequency and therefore pitch will be heard. Mathematically, this makes sense, as according to our equation, Fn equals n times square root t over mu over 2L, for a specific harmonic being studied, decreasing the length of the vibrating part of a string will increase the harmonic frequency. Finally, let's go over on how to maximize your musical experience. For string composition, the choices you make oftentimes depend on the type of music you want to play. If you are a fan of classical, flamenco, or folk music, classical guitars may be the right choice for you. Their calmer, more soothing tone are characteristic for genres such as these. Acoustic strings, when played, produce a much brighter, more vibrant tone, making them much better for rock, bluegrass, and country genres. Because classical guitars have a much lower tension, they stretch more than acoustic strings, and thus require to be tuned a lot more in order to maintain optimal tension. This can cause many guitarists to switch to acoustic strings earlier on to avoid this constant burden. A truce rod is often used by guitarists to prevent the guitar neck from bending back when strings are tightened. It slides into the neck of a guitar via a small hole just above the neck, countering the effect that string tension has in overcurving the neck. Tightening the rod by turning it clockwise allows the neck to bend back a lot less in response to tension from the strings. Truce rods are mostly used in acoustic strings, as these strings bear much greater tension than classical strings. And here are my references.